Hi guys, it's Mrs. Glenn. Let's get started on the 5.1 classwork. So first we're going to do the vocab and theorem, which there's 5 of them today, and they start on page 376. So for the first one, it's interior angles. Interior angles are angles of a polygon located on the inside of the polygon. And this figure to the left, you can see I drew a triangle with the angle symbols in the corner, and that's just symbolizing the inside or the interior angles. And then for exterior angles, also interior angles are known as the original angles. Exterior angles are the angles that are formed on the outside that actually form with a linear pair with the interior angles. So you can see the diagram I drew on the left. You have your interior angles that are on the inside of the triangle, and then when you extend the legs of the triangles out, they actually form linear pairs all the way around with exterior angles. So that angle right there with the interior angle that's adjacent to it would be the sum of 180, and then all the way around, those are exterior angles. So on the outside of the triangle, they're called the exterior angles. And then we have triangle sum theorem, and that just means that the sum of interior angles of a triangle is 180 degrees. And then exterior angle theorem, and that theorem allows you to find an exterior angle using 2 of the interior angles. The 2 that you have to choose are the non-adjacent interior angles, so they can't be next to the angle that you're trying to find. So you would find this angle measure by just adding these 2 angle measures together, and you would find what the sum of those are, and that would tell you what angle 1 would equal. And then the last one is corollary to a theorem, and all that means is it's a statement that can be proved easily using a theorem. So go ahead and pause this as you need it to be able to write down the vocab and theorem. So now we're going to do the bell work. So we have find angle 1 and angle 2 for each of the angles. So you can see angle 1 are vertical angles with 31. So that means angle 1 is 31 degrees. And for angle 2, it's part of this 90 degree, because it's 90 degrees on this side, we know that the sum of angle 2 and 31 degrees add to be 90 degrees. So if you just subtract 31 from 90 degrees, you would find what angle 2 is, which is 59 degrees. And so today's lesson is actually about classifying triangles either by sides or angles. So I just want to go over the different ways that you could do it first. So if there are no congruent sides, it is called a scalene triangle. So that means all of the sides are different lengths. If it has 2 legs that are the same or congruent sides, then that means they're isosceles. And the way that I remember this as a kid is that it had 2 S's in the beginning here, so 2 sides are congruent. And then equilateral sounds like equal, which means that all 3 of the sides are congruent. So scalene, isosceles, and equilateral is how you identify it as sides. And then for angles, you look on the inside. So acute angle triangle means that every single angle in the corners are all acute, which means less than 90 degrees. And then for a right triangle, you just have to have one angle measure is equal to 90 degrees. And obtuse means that you have one angle measure that's greater than 90 degrees. And then, of course, equiangular triangle, it just means that every single measure is 60 degrees because 180 divided by the 3 angles is 60 degrees. All right, so let's get started with number 1. Classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. So taking a look at the picture, you can see that there's a triangle with a right angle symbol in the corner. So this is a right angle, which means that all of the triangles that are in this, that are congruent to this, would have right angles. So first we can determine the number of sides that are congruent. So first of all, we don't have any kind of tick marks that are showing us that the legs are the same length. So that would be those little dashes that go through the legs of the triangle. So therefore, none of the side measures are congruent. And then that means that they must be a scalene triangle. So then we have to identify or classify the triangle by its angles. So we know that in the diagram we can see a right angle symbol. So therefore right angles equal 90 degrees. So it must be a right triangle. And then we just put it back together. So we have its therefore is a scalene right triangle. So we have to say both. We have to say by classifying by sides and also classifying by angles. All right, go ahead and pause this, like I said, as you need to be able to write everything down. And then we're going to go on to number 2. Number 2 says classify triangle ABC by its sides, then determine whether it is a right triangle. So first thing you have to do is find the distance for all of the legs. So we're going to use the distance formula. And we're going to plug it in for AB to start. So that is this leg over here using this ordered pair and this ordered pair. So x2 minus x1, and then y2 minus y1. And when you subtract, you get, subtract and square, you would get 7 squared and 2 squared, which turns into 49 plus 4, or the square root of 53. When you put that in your calculator, you get approximately 7.3 units. Then we're going to work our way around the triangle and go to AC, which is on the left-hand side. So we're going to use 0, 3, and 1 comma negative 1. And plug that into x2 minus x1 plus y2 minus y1 squared. So when we subtract and take the quantity squared and then do the other side, you get 1 plus 16, or the square root of 17, which is approximately 4.1 units. And then the last will be the bottom, which is BC. And we plug that into the distance formula, simplify, and you get the square root of 40, or approximately 6.3. So if you could see, none of these sides are the same length, and so therefore it must be a scalene triangle because they don't have any congruent sides. And then to determine if it's a right angle triangle or right triangle, we have to find the slope of each of the legs. So we use the slope formula, y2 minus y1 over x2 minus x1. I'm going to start with AB and plug it in, subtract and then divide, and I get negative 2/7. And then for AC, plug it into the slope formula, subtract and divide, and I get negative 4. And then the last one is BC, plug it into the slope formula, subtract and divide. For this one, you're going to simplify, and you get 1/3. And if you notice, none of these slopes are the same. And also for perpendicular, none of them are opposite reciprocals. So in order to form a 90-degree angle, the two lines have to make a perpendicular two lines. 1 second. Sorry, Cooper was bugging me for a second. All right, so first thing I said was right angles make perpendicular lines. So perpendicular lines are opposite reciprocal slopes, which means you flip them and take the opposite signs. And then we can see that none of them are perpendicular, so therefore it must be an acute scalene triangle. All right, going on to number 3. Find the measure of angle PQS. So if you notice here, we've got an exterior angle and 2 interior angles, and we already know with exterior angle theorem that if you're looking for this measure, you just have to add these two together and make it equal this, and you'll be able to find what the angle measure is. So that's exactly what we're going to do. We just put 3x plus 25 equals the sum of 2x and 65. And I'm just going to solve for x. So I'm going to subtract 2x on both sides first, and then subtract 25 to the other side, and I get x equals 40. And remember, they're asking you to find the measure of PQS, so the measure is not 40, it's whatever this is after you plug 40 into it. So we have to replace x with 40 into 3x plus 25. So that would be 120 plus 25, or 145 degrees. And that makes sense because this is an obtuse angle. So angle PQS is 145 degrees. All right, I'm going on to number 4. You are designing windows for a new house. The windows are right triangles. For each window, the measure of one acute angle in the right triangle is 1.5 times the measure of the other. Find the measure of each acute angle in the window indicated by the red triangle. So the red triangle is right here. And first thing we're going to do is sketch what they just told us. So we are going to make that 1.5 times the measure of the other. So if we put x in the corner here, 1.5x would go in the other corner because it's 1.5 times bigger. So you can use the corollary to the triangle sum theorem, and given the relationship, we can write that x plus 1.5x equals 90 degrees. And so if we combine like terms, you get 2.5x equals 90 degrees, divide by 2.5, and you get x equals 36 degrees. So it says find the measure of each acute angle. So we know that this corner is going to be 36 degrees because that's what x equals. And then we just plug in 36 into the other side. So instead of writing x, we write 36. Times that by 1.5, and you get 54 degrees. And just to check your work, if we add those three angles together, it should equal 180. So 36 plus 90 plus 54 all adds to be 180, so we are correct with our two answers of 36 degrees and 54 degrees. And please use this textbook pages 373 through 383 for more examples and directions if you need it to complete your 5.1 practice on big ideas. Go ahead and go to big ideas and complete your 5.1 practice. See you later.